Hey everyone, my name is Kavya Samudrala. I'm a fourth year PhD candidate here at UC Riverside in the Department of Chemistry. My research focus is in inorganic chemistry. I say inorganic because it's kind of the opposite of what everyone thinks of when they think of chemistry. Typically people think about carbon and phosphorus and nitrogen, and I do work with all those things, but I also get to work with a lot of really cool transition metals. So my work, I get to also focus on how those organic things also interact with things like zirconium and tantalum and some palladium and nickel, which is actually quite fun. Now, the research that I do broadly falls into this umbrella term we call fundamental chemistry research. Now, that's kind of a misleading term, right? Because chemistry is one of the oldest physical sciences, and what is there left to be discovered that's fundamental, right? But you'd kind of be surprised. So there's a lot of fundamental research problems that chemists still focus on answering, and that's kind of what keeps things fun for people like me. Now, the research I do specifically involves making catalysts. Catalysts are, believe it or not, everywhere. If you've filled your car with gasoline recently, gasoline is a product of a catalytic process. If on your clothes you see a little label that says, X% polyester or Y percentage rayon, anything like that, those are all synthetically derived fibers, and they are made out of catalytic processes. If you're wearing a mask similar to me, right, these surgical masks, these are made out of polypropylene, and polypropylene is also something that is made from a catalytic process. So we've all been in contact with plastics we've all been in contact with something that's derived from a catalyst more than you think, which is quite fun. Now, the reason a lot of the work I do is really important is because I focus on how to make a lot of these catalysts better. What I mean by that is, a lot of the problems that we have in the world right now, one of the biggest problems we have in the world right now is climate change. Now, climate change has manifested in a few different ways, right? The increased emission of greenhouse gases. Greenhouse gases are made out of very small molecules, things like methane and carbon dioxide instead. The catalysts I make are really, really sensitive and very, very reactive. That's really good because hopefully these catalysts are active enough to activate and capture and reuse things like carbon dioxide and methane. And that's probably one of the best parts of my research, I think. In addition to that, my lab also is looking into ways to decompose things like plastics, which is very cool, right? Plastics are everywhere. We've talked about how even like face masks are made out of plastics, right? And the research I do focuses on understanding the catalysts that make these plastics in order to try to figure out how to make them even more active to ideally break down these plastics. Now, this research I think is more important now than ever before, continues to be very important. And it's very fun to do a lot of this fundamental research. Putting the fun back into fundamental, right? Sorry. Anyways, I really enjoy the work I do here at UC Riverside, and I'm hoping that you guys also enjoyed hearing about it. Thank you for your time. I'd like to thank the Associated Students, the Associated Students Board here at UCR, in addition to HDR, Nature, the Solus Group, the American Chemical Society, the Office of the Provost, UC Riverside, as well as Elsevier and SciComm at UC Riverside. So thank you guys. I hope you enjoyed my talk.